How does an AI coding agent actually know its code is done? Not looks fine to me, not vibes, provably, in one command. This is the quality gate every Python project needs and every agent can use. Here is the problem. An agent writes code fast, really fast, but verifying that code is a different story. A human glances at it and says, looks fine. An agent cannot glance at anything. It needs a deterministic answer, a yes or a no, pass or fail. The big idea is almost embarrassingly simple. One command runs a gauntlet of tools. If they all pass, it exits 0. Ship it. If any one fails, it exits non-zero and tells you exactly which tool and exactly what broke. That signal is all an agent needs. This is the whole thing. A single makefile. Each target is one tool, one job. Format, lint, type check, tests with coverage, quality checks, security scans, build, install, and 2 composite targets at the bottom. Check runs the fast gate. Pipeline runs everything end to end. Read it top to bottom. That is the entire system. The magic is composition. The check target is just a list of other targets. Make runs them in order, and the moment one fails, it stops. So the agent always knows the first thing that broke. Pipeline is the same idea, plus build and install. One target, many tools, one verdict. Where does each tool get its settings? Right here in pyproject.toml, next to your code. Ruff's line length, mypy, set to strict. Coverage, what to measure and the floor to enforce. Bandit, which checks to skip. One file, all the thresholds, version controlled. No hidden config, no editor-specific setup. Windoc. And see that dev block, that one group installs every tool the Makefile calls. And because every target carries a double hash comment, make help documents the whole thing for free. Your CI, your agent, and your future self all read the same menu. No wiki page to forget to update. The Makefile is the documentation. First gate, format and lint. Ruff. It enforces a consistent style, sorts your imports, flags unused ones, and modernizes old syntax. It catches the cheap problems, the ones that waste a reviewer's time, before a human or an agent ever sees them. 2 commands, format and check, and your code looks like one person wrote it. Here is the loop in miniature. The agent runs make lint. Ruff says, line too long, here is the file and line. The agent reads that, wraps the line, runs it again, all checks passed. That is the entire job, repeated for every tool. Read the error, fix, rerun. Next, types, mypy in strict mode. Tests tell you the code does the right thing. Types tell you it cannot do the wrong thing to the wrong shape of data. MyPy catches the bug your tests never thought to check, the null that isn't there, the int where a string snuck in. Strict means no silently untyped functions, every parameter, every return accounted for. Now correctness with a coverage flaw. Pytest runs the suite, and coverage measures which lines actually executed. Fail under sets a minimum. If your coverage drops below the threshold, the gate fails. So deleting tests or skipping them has a cost. The number is a contract. Coverage isn't magic either. You configure it. Source is your package. Branch is true, so it checks both sides of every if statement. Omit excludes things you genuinely can't unit test, like command wrappers that need a live API key, and the threshold is the flaw you commit to. Quality Gate Part 1. Vulture finds dead code. Unused functions, unreachable imports, leftover variables. It does have false positives, decorators, and enum members that look unused but aren't, so you keep a small whitelist file with a comment explaining each entry. Anything not whitelisted has to go. Less code, fewer places for bugs to hide. Part 2. Xenon is the complexity gate. It grades every function, A to F, by how tangled it is. You set a ceiling, say grade C. Any function worse than C fails the gate. Complexity is where bugs live. Cap it and the codebase stays refactorable, even as an agent keeps adding to it. Part 3. radon. It reports the same complexity as a grade, plus a maintainability index for each module. This one does not fail the build. It is a dashboard. You watch it over time. If a module drifts from A down to C, you know exactly where the rot is setting in before it becomes a crisis. Security Tool 1. Bandit scans your own code for dangerous patterns. Hard-coded secrets, shell equals true. Weak hashes, SQL injection. Each finding comes with a code, and you can skip the ones you've actually thought about with a comment saying why. It turns security from a feeling into a checklist. Tool 2. Pip-audit. This one doesn't look at your code. It looks at your dependencies. It checks every installed package against the known vulnerability database. Your code can be perfect and still be insecure because of a library you pulled in 6 months ago. Pip-audit catches that automatically on every run. Tool 3. Gitleaks. It scans your entire Git history for secrets. AWS keys, tokens, private keys, anything that looks like a credential. Because secrets don't just live in your current code. They live in commits you forgot about 3 months ago that you pushed that are now public. Gitleaks reads every commit every time. Stitch it all together, and this is the pipeline. Format, install, lint, type check, coverage, quality, security, build, install. 14 stages, 1 command. If it reaches the end, exit 0, shippable. Any red light along the way, and you know precisely where and precisely why. If you are keeping score, that is the taxonomy. Style, types, correctness, code health, security, 5 families, 10 tools. Each catches a different class of mistake. No overlaps, no gaps. Every common way a Python project goes wrong has exactly one tool watching for it. And here is why this matters for agents. The loop. The agent writes code, runs make check. Exit 0 means done, ship it. Anything else, and the agent reads which tool failed, applies a targeted fix, and reruns. That feedback loop is the engine. It is how an agent decides what to fix, on its own, without a human in the loop. The Makefile is the agent's definition of done. In practice, it looks like this. The agent runs make check. Ruff finds a long line, and the gate stops right there at lint. The agent opens the file, wraps the line, runs it again, lint green, types green, tests green, coverage met, security clean, exit 0, done. No human had to look at the diff to know it was safe. Want it in your own project? 3 steps. 1. Drop the Makefile in and swap your package name into the 4 targets that reference it. 2. Paste the dev dependency block into your py project. 3. Set your coverage threshold. That is it. You are live. Any Python project, any package manager that runs the commands. And it is yours to tune. Raise the coverage floor over time as your tests grow. Tighten the complexity gate from C to B. Add a tool by appending 1 target and chaining it into check. The Makefile is plain text. The thresholds live in pyproject. The whitelist documents your exceptions. Nothing is magic. Nothing is locked in. 1 command, 1 exit code. That is the definition of done. Deterministic quality for any Python project, and the perfect signal for any AI agent you pair with it. Copy the Makefile. Tune the thresholds. Ship green.